Hey guys, welcome back. So today we're going to be talking about compound inequalities. Let's go ahead and write down today's objective. I can graph compound inequalities. Now there's two different types of compound inequalities. We have the and compound inequality and we have an or compound inequality. Now to help you understand the differences between them, I have this Venn diagram, a couple of Venn diagrams that will help you try to understand the difference between the word and the word or. Now, in this category right here, these categories are representing students that like Burger King, and these are representing students that like McDonald's. Over here, these are students that are Sox fans, these are students that are Cubs fans. Now, just so you know, any number inside a circle is part of that category. So over here, this circle has the number 3 and the number 4 in there. Therefore, there are 7 people total that like Burger King. Now these same 3 people are inside the McDonald's circle, so we have 20 people that like McDonald's. Now what I want you guys to do is answer these 4 questions, and then we're going to talk about them and see what the difference is between and or. Go ahead and do that right now. Okay guys, so over here we have how many students like McDonald's or Burger King. Now if I made this a yes or no question, and I asked this group of people over here, I said, do you like McDonald's or Burger King? They'd say yes, because the yes part goes with the Burger King. Over here, if I said, do you like McDonald's or Burger King? They'd also say yes. And in the middle, this number 3 is in both circles, so obviously they'd say yes, because they actually like both of them. All right, so all these numbers would say yes to liking McDonald's or Burger King. So you'd add them all together, we'd get 24, and we put it right over here. Okay, now over here we have how many people like McDonald's and Burger King. Now for you to like McDonald's and Burger King, you'd have to like both of them. Over here, if I ask this person, this is a yes or no question, do you like McDonald's and Burger King? They'd say no, because they don't like the McDonald's. Even though they like Burger King, they don't like McDonald's, so they would say no. Same thing over here. They would say no because they don't like the Burger King. Now over here, if I ask this group right here, do you like McDonald's and Burger King? They'd say yes, because you can see that the 3 is in both circles. So therefore, there's only 3 people in this scenario that like McDonald's and Burger King. Now over here, we have Sox fans and Cubs fans. It says, how many students are Sox fans or Cubs fans? Now if I made it a yes or no question, I go up to these people right here. Are you a Sox or Cubs fan? They'd say yes, because they're a Cubs fan. If I said, are you a Sox or Cubs fan? They say yes, because they are a Sox fan. So these two put together, getting you 17, would be the answer to someone who is a Sox fan or a Cubs fan. Now if I said, are you a Sox fan and a Cubs fan? This guy would say no, because he's not a Cubs fan. He's only a Sox fan. Same thing over here. They would say no, because they are only Cubs fans. So if I asked the question, are you a Sox fan and a Cubs fan? You would find nobody, because these circles are disjoint. So it would be no solution. Okay? Now, the difference between and or when it comes to the inequality. What I want you to write down for and is when you have a solution to both categories. Okay, like over here, the solution to both categories was the 3, because the 3 is in both circles. Okay, it's because this person likes McDonald's and Burger King. The solution over here was no solution, because there is no one in both circles. Okay, so for the and, they have to say yes to both. So they have to both be shaded. Now, what you want to put here is overlapping shading. Now this is going to make more sense when we go to the next slide. Now for the or, what I want you to write for this one is when you have a solution to at least one of the categories. So again, everyone here said yes when I used the word or, because again over here, are you do you like McDonald's or Burger King? They say yes, because they like Burger King. Over here, are you a Sox or Cubs fan? They'd say yes, because they're a Cubs fan. So that included every number that's on here. Okay. Now what I want you to write over here is anything shaded. So anything shaded would be part of the solution. Okay. Now let's go ahead and write down the definition of a compound inequality. A compound inequality consists of 2 inequalities that are connected by an and or an or. And as you can see here, number 1 and number 2 are both the same. The only thing that's different is number 1 has an and number 2 has an or. So this is what it's going to look like when you graph a component inequality. Now, you're going to start out by looking at the numbers. Over here we have a 3, over here we have a -1. We put them in order, so we're going to put the -1 first and then the 3. All right, then we're going to look at the signs. Now this sign right here has an or equal to bar. Therefore, I'm going to put an open circle, a closed circle. Over here, I do not have an or equal to bar, so I have a open circle. Now we're going to shade, not shade, but we're going to draw lines on here. The way that we used to draw lines was we used to look and see what test point would work. So over here, if you put a test point, the number that would work for this one right here would be -100, because -100 is smaller than 3. -100 is towards the left, so what I want you to do is draw an arrow coming up and out to the left. Okay. Over here we have 100 that would work. 100 is greater than -1, so the arrow would be going out and to the right because 100 is on the right side. Okay, now the word and, I want you to draw an arrow coming out of that and I want you to write the word overlap. So overlap means that both have to be there, both have to be present. Now we have 3 sections of this number line. We have the green section, we have the blue section, and then we have a green and blue section. Again, this is an and problem, so you have to find out where there's green and blue. The green and blue are only located in this middle region right here. Okay, now over here we have an open circle. So since it's an open circle, this is technically only a blue region. Over here we have a closed circle, so blue, and then we also have green, so that means we would include -1. So just remember that if there's an open circle, a closed circle, then you're going to include it in an and problem. Okay, now what I want to do now is come up with a couple of test points. Now anything in the red region is going to be a solution. So the numbers between the red would be like -1, 0, 1, 2. Now again, -1 because that is a part of the solution. That's a closed circle. Over here, this is an open circle, so that's why we're not including 3. And then also any number in between these, like 0.5, 1.5, -0.03, those would all be solutions as well. Okay. Now let's take a look at what this would look like if we had an or instead of an and. Now the first part of this is pretty much the same as what we did up here because we have everything that's the same except for the word or in there. So we're going to plot the -1, plot the 3. We have a closed circle for the -1. We have an open circle for 3. Okay, the arrow for the 3 would be going up and to the left. The arrow for the -1 would be going up and to the right. Now, draw an arrow pointing out of the or, and what I want you to write this time is anything. So anything that is that has some type of color is going to be a solution. So this is the blue region, this is the green region, this is the blue and green region. Now again, every single one of these regions has a type of shading. Therefore, what we would say is the whole thing is a solution. So every single number on this number line is a solution. So when I say every single number on the number line is a solution, what that means is it's all real numbers, okay? So all real numbers would be the answer to number 2. Now if you need to press pause, go ahead. Otherwise I'm going to go to the next slide. All right, now for this next one, we do have the same inequalities again. We just have different. This one's an or and this one's an and. Now I'm going to help you start number 3, but then I'm going to ask you to finish it up. So for number 3, we have -2 and we have a 5. Now looking at the -2, we know that it's going to be a closed circle because we have that one. And then this one's going to be an open circle because we have no or equal to bar. Okay, now this time over here we have, let's say that we put -100 in here. -100 is smaller than -2 and that's towards the left. Over here, 100 is bigger than 5 and that's towards the right. Okay, now this is what the graph is going to look like. Now what I want you to do is I want you to shade the solution and give me some numbers that would work. All right, so the region that would have to be shaded would be, again, this is an OR problem. So this is anything shaded. So this is shaded, so I'm going to include it. This is shaded, so I'm going to include it. Now we have an open circle here, so we would not include the 5. We have a closed circle here, so we would include the -2. Okay, so that's what the graph should look like. Now, when you when on the side where it says what are some solutions, now yours might not be the same as mine, but as long as it's in the same region. Now, the region I'm talking about are the numbers that are before the -2. So like -1,000, -15. We would also include -2 because that's a closed circle. Over on the other side, we would not be including 5, but anything after 5 would be included. We got 6, we got 17, we got 40,000. So these are all solutions because it's an OR problem, so anything. Okay, now let's take a look at number 4. Again, let's graph this together. So we have the -2, we have the 5, we have a closed and open circle. The arrow coming out of the blue one, out of the -2, would go towards the left. The arrow coming out of this one would be going towards the right. And then we're going to go ahead and find out what side to shade by looking at the word. The word this time is and. Okay, and remember, and means overlap. So what I want you to do is tell me where the overlap is and tell me what are some possible solutions. So hopefully you got this one right. Now, if you look, there's, again, 3 regions here. This one has blue, this one has nothing, this one has green. Therefore, it is no solution because there's no overlap, okay? So what we're going to do over here is we're going to say that some possible solutions, there are no solutions. So we can put the circle with the line through it. All right, so let's go ahead and take a look at number 5. All right, for number 5, we have 4 and we have 10. So you're going to plot the 4, we're going to plot the 10. Okay, we're going to put, for this one, this would be an open circle. This one would also be an open circle because there are no or equal to bars. Now, for the blue one, the number that would work is 100, so we go towards the right. The number that would work in this one as well is 100, so we would go towards the right because 100 is bigger than 10, 100 is bigger than 4. Now, this is an and problem, so I want you to try to figure out where the overlap is, and that's going to be the answer, and then give me some solutions. All right, so the only place that we are talking about for this one is going to be the right side of the equation. Now, this is an open circle, so we are not including this because this is only a blue region technically because that's an open circle. All right, so some possibilities. Now again, yours might not be the same as mine, but as long as it's in the same area, because all the numbers on this side would be the solution. So like 12, 19, a million, all these are solutions, okay? Now number 6, we're gonna graph it again. So we got the 4, we got the 10, 2 closed circles, so 2 open circles, and the arrows are still going the same way because we didn't change the inequalities. Now the fact that we have an or says something different. Go ahead and try to figure out what it is and give me some solutions. All right, so now any place that has at least one shading. So this has both shadings, so obviously that one would work. This right here has the blue area, so that would work. Now over here there's nothing, so we would not include that. Now, you see how we have an open circle? We are not including the number 4 because there's an open circle there. So some possibilities for this would be anything after 4. So we have 5, 6, 7, 8, 9. Now before 10 wasn't a solution because it was an open circle, but now you see it's still an open circle, but we still have this blue line going above it. So therefore it's 10, all right? And then anything else that was up here would also work. So 12, 19, and a million. Those would work as well. Okay, now for the last one, all right, I'm going to help you graph these, and then you're going to go ahead and tell me what you think the solutions are. So for number 7, there is only one number. They're both 7. You guys can see that, right? So we have 7, and we have 2 separate inequalities, so we have to think of them as 2 separate inequalities. Now this is an or equal to bar, so there's going to be a closed circle. So I put a blue closed circle. This one is also an or equal to bar, so we're going to put a blue closed circle again. Okay, sorry, a green closed circle. Okay, so now what we're going to do is we're going to draw the arrows. Now for the blue one, this is saying that 100 is greater than 7, so we're going to be going towards the right. This one is saying that 100 is, negative 100 is less than 7, so we'd be going towards that side. Now again, for and, it's overlap. Try to figure out where there's overlap, and that is the solution. Go ahead and do that right now. All right, so the overlap is, if you look over here, this is only green, so nothing on this side works. Over here, this is blue, so nothing on this side works. The only place there's overlap is right here, where there's a blue and green dot. So that is the solution right there. So when it says, what are the solutions? Well, there's only one. That one solution is 7. So that's why we have just a dot on this number line, okay? Now the next one is different because we do not have or equal to bars. So when we put that 7 in there, we're going to have an open blue circle and an open green circle, okay? So the shadings are going to be the same. The green side is going to go to the left, the blue side is going to go to the right. What I want you to do now is I want you to tell me what is the possible solutions. Go ahead and do that right now. All right, so over here there's blue, so it counts. Over here there's green, so it counts, because again, anything that's shaded counts, and we're going to include it as a solution. So the blue side's going to get some, and then the green side's going to get some. Now, you notice I didn't put any red in here, because these are both open circles. Since they're both open, there's no shading there. Therefore, it kind of looks like it's all real numbers, but it's not. It's all real numbers except the number 7, okay? Now, hopefully you guys understood. We're going to do some practice on Monday, so I'll see you guys. Have a good weekend.